Hi, I'm Michael DeBellis, and I'm going to be discussing a project I did with Nivedita Duda to develop a semantic search tool for dental clinicians by integrating ChatGPT and ontologies to create something called a retrieval augmented generation architecture. This project started approximately 2 years ago. Nivedita is a PhD in dentistry and a dental clinician, and she wanted to create a tool to help clinicians get the information they need to effectively treat their patients. This is an important problem, even more so in some ways with dentistry, because the field of dental materials is constantly evolving due to progress in the underlying science, such as the creation of new kinds of materials, new kinds of techniques, such as lasers, and so on. So getting clinicians, the most up-to-date information is a really important problem. So Nivedita learned OWL and then began developing an ontology in order to solve this problem. I helped her with this initial ontology, which we presented at FOIS 2023. Then the next phase of our work, which we began in January of 2024, was to use the ontology as a semantic search tool for journal articles and other relevant documentation. And as we evaluated the architectural options for this tool, two problems were the most difficult. The first was, how do we model the meaning of the text in our corpus? And the second was, how do we provide a user interface that clinicians would find easy to use? In the previous project, we had competency questions and we had Sparkle. We implemented those competency questions in Sparkle, but of course we don't expect clinicians to learn Sparkle. So I asked some colleagues I have at Allegrograph if they had any ideas, and luckily enough, they did. So they recommended a new version, which at the time was not released. It is now. This was back in February of 2024, of Allegrograph, which would include integration between the knowledge graph and ChatGPT. And this looked really promising. However, it did bring to mind a very natural question. Well, could we just use ChatGPT? So we tried that first. We tried taking the competency questions that we developed for our initial ontology and asking those to ChatGPT. And while the answers often looked impressive, in fact, Nivedita is writing another interesting paper about the experience of having clinicians try using ChatGPT. What we found is the answers were almost always incomplete or in some ways wrong. And so that's the problem that I'm sure most people are familiar with, called hallucinations. The other problem is that the LLMs do not provide references for where they got their answers. So that's the second problem of black box reasoning. So that's where we turn to this problem of this architecture rather, of retrieval augmented generation to solve these two problems, hallucinations and black box reasoning. So retrieval augmented generation does this by replacing the shallow but broad knowledge base of the LLM with a narrow but deep knowledge base on a specific domain. That's what the RAG architecture is all about. Rather than use the LLM just as a black box, you look inside the LLM with APIs from, in this case, OpenAI, and you use the various modules that communicate to each other, and that's usually, of course, not something that the user sees, and you can use those modules piecemeal to perform certain operations for you, but you can also essentially replace the domain knowledge of the LLM with your much deeper and much more focused and curated domain knowledge from your domain. So the retrieval augmented generation solves both those problems of hallucinations and black box reasoning. It also solved both of our design problems. First of all, it was able to capture the meaning of text by vector embedding. And second, it was able to provide a very intuitive user interface by using the ability of the LLM to converse with users via natural language. So this slide shows the data pipeline for creating vectors for the corpus. So this is a batch process that needs to be done once to set up the corpus, and then repeated every time we need to want to add new documents to the corpus. So to begin with, Nivedita did searches and sources such as PubMed and saved the metadata from each search to a CSV file. Then I wrote a Python program to upload those CSV files into the knowledge graph. So each row in the CSV file was a new object, and each column in the CSV file was a new data property from metadata for the document. Then step 2 of this process was to post-process these objects, to go from strings to things. So to take some of the data properties and turn them into objects and object properties. So for example, one example was where one of the bits of metadata is a URL to the actual document. So to get the actual text for the document, we would follow that URL. We then used another Python program built on a library called Beautiful Soup to analyze the structure of the document, the sections and the subsections, turn that into a structured object and sub-object. So we have an object called section, and it has an object pointer from the document called has subsection to each subsection of the document. And in the post-processing, we created that structure. We did other things too, like creating objects and object properties for each of the authors, and so on. And then the final step of this process is then to analyze the data properties with text strings that we wanted to create vectors for. In our case, this was primarily the abstract and the text strings that are associated with each section. And by the way, one of the reasons we want to do that is because if you send too large a section of text, like if you send a complete document, a journal article, for example, to ChatGPT, it will break the OpenAI API. The OpenAI API for vectors will reject that because it doesn't want to create a vector for such a large bit of text. And the main reason for that is because doing so is just too general. You want to divide the documents up into smaller components, because that way the vectors that you create are going to be much more focused. And when you're using those vectors and when you're giving citations back to the end users, you'll be able to give them much more focus rather than saying, well, it's somewhere in this paper. You'll be able to focus them on the exact specific text of the paper that relates to the specific question that they asked. So this next slide shows the runtime architecture of the system. So step 1 is the clinician asks a question. And remember, as I was saying, we're using different modules of ChatGPT. So one of them is something called the ADA 003 module. And that's step 2, where the ADA 003 module, that's the thing that generates vectors from text, generates a vector for the clinician's question. Step 3 then is that the Allegro graph using Sparkle finds the nearest neighbors within a threshold and that are within a certain semantic distance of the vector, of the question vector, and it returns all of those objects. And this is performed via Sparkle query, and the query also returns other objects that are relevant to the question. Then in the final step, all those objects, so the vectors for the question, the vectors for the answer, are all then set to the module in ChatGPT that takes in those kind of vectors and then generates an answer. So, we're still using the ability of ChatGPT to understand and to provide answers in natural language, but we're not using the knowledge of ChatGPT. We're substituting our knowledge, our much deeper and more up-to-date knowledge instead, and also because our knowledge has a certainty factor that also prevents hallucinations, and because we have direct links to the sources that we use for our answer, that answers the question of black box reasoning. So in the next few slides, I'm going to go through a simple example. So first, here's one of the competency questions. And as you can see, ChatGPT says that it doesn't have enough information to answer the question directly. And that's because it doesn't have one of the latest papers that is in our knowledge graph. So this, excuse me, this next page shows our user interface for the RAG system. And as you can see, here's the same question. So the way this works is I'm using a very simple Python program called Streamlit.io that's a servlet, Python servlet. And when the user types a question into the box in the upper left, that triggers a program that runs a Sparkle query, which I'll show you in the next slide. And as a result of that, we go through that runtime architecture that I showed in the previous slide. And assuming that the system finds at least one good answer for the question, then the answer goes in the box below on the left, and then the supporting documents are shown in the right in that long scrollable window. And then in addition, you can see in the at the bottom where I've drawn a little red box around it, there's a link called View Answer Graph in Gruff. That allows the user to then do additional exploration of the knowledge graph to find more information than what was given by the system as the initial answer to the question. So this is the Sparkle query that's used. So in the servlet, I have a template that has this query more or less built into it. And one of the reasons that it has this IRI that says OBO colon IAO with the number is that we used a lot of the entities from the OBO oral health and disease ontology, and of course this is the standard for OBO entities. And what that specific property is it's called is about. So it's a very general property that relates a document to any topic or any entity in the ontology that the document is about. So that's what it means here. The other ones are from our model, so those are intuitive. But the reason I have all the optional parts of the query is because I had to set it up to deal with two different scenarios. So in one scenario, the text that we're using for the answer actually comes from the abstract of the document. So in that scenario, the abstract is actually a data property of the document itself. And so in that scenario, we just have the document already. The second scenario, the text we're using for the answer comes from the document itself. So in that case, if you recall, we divided the document up into a bunch of section objects. So in that case, the text is coming not from the document itself, but from a section object. So I have to trace backward, and so you can see that has subsection. I'm tracing back from the citation, which was a section object, to the actual document. Then I actually have the document, and then I can use the other properties to find the relevant links for for this particular query. So now this next slide is showing what happened when I clicked on that little link at the bottom of the interface that said show knowledge graph objects in Gruff. So the Gruff browser is a very powerful tool that's part of Allegro Graph for graphically visualizing a knowledge graph. So the way we do it is we start out by taking all of the objects that were the result of that query in the previous slide, and we throw those into Gruff, and then we bring up the initial graph. So you can see here in the initial graph we've got the document as well as the authors and as well as the topic that the document is about. Now we can then further analyze, further explore the knowledge graph by all sorts of ways of exploring the knowledge graph utilizing Gruff. And I'm only going to show two very small examples. There are like many ways. It's one of the things I like about Gruff is there's countless ways to reformat the graph, to visualize it, change the way it's laid out, to expand a node, contract a node, and otherwise explore the graph visually. So in this case, all I did is I selected one of the nodes for the authors, Matej Par, and I said, show me all the has author properties that have Matej Par as the object, but that aren't yet displayed in the graph. And so the graph then now shows me two more documents that Matej Par is the author of. Then one other example I can do is I can also click on any node and I can use a keystroke to show, is there a URL associated with this node? So again, I'm using Matej Par here as an example. I clicked on him. I did the keystroke to show me the URL associated with Matej Par, and that brought me to his ORCID ID page. Another example would be I could click on any of the documents, use the keystroke to show me the URL for the document, and that would take me to the journal site with the specific article, in the browser for the article that I clicked on in the graph. So one of the most important questions, which I admit we don't have a good answer for right now, is have we used this with actual clinicians? And unfortunately, we haven't. So far, the project's been very small. It's just been myself and Nivedita. We don't have any funding yet. We're both working on it because we think it's an interesting and important problem. We're hoping in the next phase to get some funding available for postdocs in India and to use that funding to help put the site up on Amazon Web Services. And Nivedita already has some clinicians lined up. In fact, she's also done some interesting research, which she hasn't published yet, but hopes to soon, on where we had some clinicians evaluate just using ChatGPT and did some analysis about, their evaluation of ChatGPT and what that can tell us. Obviously, the next thing that we want to do, and the most important thing, is to take this system and put it up on the internet, and then that will enable actual clinicians to go through and use it and give us feedback. Another really interesting issue is that ChatGPT keeps getting smarter. So specifically, most of the competency questions that it gave very bad answers to back in February, when I tried them again in May of this year, the answers were much better. And so there's sort of an arms race essentially between the RAG system and the LLM, because the LLM keeps getting smarter because it's got all these resources pumped into it, by people like OpenAI. So the RAG system needs to keep getting smarter because there's going to be new papers that are coming out, and we need to keep on updating, using that pipeline that I showed on slide 4. We need to keep on going through that process to update the RAGs, our knowledge graph, with new documents, and to parse them and to create the relevant objects. And right now, that process I showed on slide 4 is a very manual process. So Nivedita does a search manually. She saves the metadata and is in a CSV file. I then run the Python program that processes the CSV file. I run other Python programs to do the post-processing. I run a Linux shell routine that generates the vectors. So it's fairly time-consuming. And what we want to do, obviously, is we want to eventually automate that process as much as we can. And that's where we plan to spend a lot of our work. The other thing is that, we as we've been looking at the difference between ChatGPT and the RAG system, it's clear that there are going to be questions, because the RAG is deep but narrow, there are going to be broader questions that would be useful for a clinician to have the answer to. So what we want to do eventually is have an interface that allows the clinician to see the answer both from the RAG and from ChatGPT, give the clinicians a bit of training so they can understand what a hallucination is, why they should trust the RAG more, but why it still might be possible, as long as they do some due diligence, to get some value out of ChatGPT as well. And that's kind of our long range goal. There's other improvements of the interface that we want to make as well, but those are the major things we want to do in the next phase. So for technical questions, here's my email. Feel free to email me. For domain questions, feel free to email Nivedita. I've got the GitHub repository for our system, the link for previous paper for FOIS 2023. And I also wanted to thank the people at Franz who were really generous in giving us a pre-release of their LLM integration and answering a lot of my questions about how to use it. Also, the people in OBO, the Oral Health and Disease Ontology group, gave us a lot of support in using their ontology as a foundation for our ontology. And everyone was very helpful from that group, but especially Bill Duncan was especially helpful. And every project, I always like to thank Protege, because I think it's a great tool and because I always get amazing support from all the people in the Protege user support email list. Okay, thank you very much.